Hello students, in our today's class, I'll just discuss about general characteristics of group 13 elements. Okay, here general characteristics means we'll discuss about atomic radius, ionization energy, electropositivity, oxidation states and their compounds nature and density. Okay, melting and boiling points also. So let us see the atomic radius, how it varies in the group. Okay, so atomic radius means what first? Let us discuss the definition of atomic radius. The distance from the center of the nucleus to the valence shell, which consists of electrons. This particular distance is called as atomic radius. The distance from the center of the nucleus to the valence shell, which consists of electrons in it, is called atomic radius. Okay, so if we observe these group 13 elements, boron, aluminium, gallium, indium and thallium, from top to bottom, atomic radius will increase. Okay, so why atomic radius increases in any group? So if we observe boron, it is having electronic configuration 1s2, 2s2, 2p1. If you observe aluminium, it is having electronic configuration 1s2, 2s2, 2p6, 3s2, 3p1. So if you observe, it is having two shells. This is first shell and this is considered as second shell. Aluminum, if you observe, it is having first shell, it is having second and third shells also. So from top to bottom, number of shells are increasing. From one element to other element, number of shells increases. As number of shells increases, the nuclear attraction on the valence electrons decreases. So due to the decrease in the nuclear attraction, it cannot attract electrons towards itself. The size will be increases as number of shells increases. From top to bottom, the size of the any atom increases. Okay, so we can say that boron is having a small size and thallium is having large size in this particular group. Okay, so next coming to ionization energy. Ionization energy or ionization enthalpy is same. Okay, so ionization energy means what? The amount of energy that is required to remove electrons from the valence shell. So I want to remove this electron now. If I want to remove this electron, I need to apply some energy. Why? Because it is having nuclear attraction on it. So nucleus is always positive in charge. It attracts electrons towards itself. So I need to remove electrons means I need to apply some energy. That energy is called ionization energy. The energy required to separate electron from the atom, from the valence shell, is called ionization energy. So if I remove first electron, if I remove the first electron, then it is first ionization energy, represented with IE1. If I remove second electron, then it is IE2. If I remove third electron, then it is IE3. Like that, values will be there. Okay. So from top to bottom, ionization energy decreases. Why? Because as size increases, nuclear attraction on the valence shell decreases. As nuclear attraction decreases, IE values will decrease. Okay. So IE1 values will be less. Okay, if I remove the first electron from the valence shell, it is having less nuclear attraction, so IE1 values will be less. But IE2, next IE2 will be more. Why? Because the electrons in the second shell, that is second orbital, that is NS, is paired. Paired electrons will have some attraction with each other. If I remove this electron, if I want to remove the paired electrons, I need to apply more energy. That is the reason IE2, IE3 will be more in nature when compared to IE1. Why? Because IE1 means it is unpaired electron, we can simply remove the electrons. But IE2 onwards, these paired electrons, and they are nearer to the nucleus, and the paired electrons, we need to break the forces between the paired electrons. That is the reason IE2 and IE3 values will be more. Okay, remember IE1 values, ionization values decreases from top to bottom when compared to group 1 and group 2 elements. Okay, next coming to electropositivity. Electropositivity means what? The tendency of an element to lose electrons to form a positive ion. So here remember the difference between ionization energy and electropositivity. Here we are removing the electron by applying some energy. But here we are not removing electron. It is the tendency to lose electrons. This element particularly has tendency to lose electrons. That tendency is called electropositivity. So this electropositive nature is particularly observed in case of group 1 and 2 elements. So if you observe group 1 elements, hydrogens family, and group 2, we have a magnesium family, magnesium elements, group 2. So this beryllium magnesium family will have more electropositivity as they are electropositive metals. But here we are having the small size when compared to group 1 and 2. Okay, small size and less electropositive values. So these elements will have a less electropositive nature. Okay, so less electropositive nature is clearly observed in case of this group elements. Okay, so we can say that boron is less electropositive element because of this small size, but from top to bottom electropositivity increases. Okay, aluminum is more electropositive than boron, but boron is less electropositive because of its small size, and these elements will have a somewhat more electropositivity. So we can say that electropositivity increases from top to bottom. Okay, so now let us see some more general characteristics. To the next one, melting and boiling point. Okay, so what do you mean by the boiling point and melting point? Boiling point is nothing but, for example, if I take this liquid in the container, so in liquid the molecules are little bit closely arranged than gas. So if I heat this liquid, the attractive forces between the molecules will break and it convert into gas particles. So the point where the liquid is converting into vapor or gas, that point is called as a boiling point. Similarly, the point where the solid is converting into liquid, for example, I am taking some ice in a container, and if I leave outside for some time, it is changing into liquid state. That's at certain point it is converting into liquid. That point is called as a melting point. So now coming to this concept, as size of the atom increases, the attractive force between the nucleus to the electrons decreases. That means it cannot attract other atoms also towards itself. So we can say that as size increases, attractive force decreases. So here also there is a less attraction and then no need to apply more energy to break the forces. Hence we can say that it reaches boiling point very easily. Whenever you started heating this particular solution, it immediately converts into boiling, that is immediately converts into vapor because attractive forces are very less, so boiling point also becomes less. So as size increases, attractive forces will become less and boiling and melting points will become less. So boiling and melting points decreases as size increases. Next, coming to density. Density is the formula of density is nothing but density is directly proportional to mass and inversely proportional to volume. So as atomic number increases, we know that atomic mass of the elements increases. So as mass increases, the density of the elements also increases. Okay. So now oxidation state. So what do we mean by the oxidation state? The charge that is present on element by involving in the bond formation. That means, every element loses electrons or gains electrons or shares electrons in order to get the noble gas configuration. Here also these elements loses the valence electrons. So you can see NH3 and P1 is a valency of these elements. They lose 3 electrons and gets plus 3. So whenever element loses electrons, it gets positive charge. Whenever it gains electrons, it gets negative charge. So it is losing 3 electrons means it gets plus 3 oxidation state. Okay, and all elements exhibits the plus 3 oxidation state. Along with that, gallium, indium, thallium exhibits the plus 1 oxidation state also, because here from here onwards you will get D and F electrons. So D orbital and F orbital having poor screening effect. They cannot screen the valence electrons. They cannot screen the valence electrons more rapidly, more effectively. So what happens? This NH2 electrons are attracted more towards the nucleus. That means they won't involve in the bond formation. That effect is called as a inert pair effect. Okay, so the ability of valence electrons to not involve in the bond formation. So these electrons, it does not involve in the bond formation. Only if these electrons involve in the bond formation, then we will get plus 1. If it loses only this NP1 electron, it gets plus 1 oxidation state. In some cases it loses all the 3 electrons, then you will get plus 3 oxidation state also. Okay. Next, coming to nature of compounds. So nature of compounds means we'll discuss covalent bond compounds and ionic bonded compounds. So these elements exhibits, some elements form covalent bond formation, some elements involved in the ionic bond formation. So boron, because of small size, it cannot lose electrons easily. Already we have discussed electropositivity. So as size increases, electropositivity increases. So they lose electrons and form ions easily. So boron cannot lose electrons easily. Hence it involves in sharing covalent bond formation. So due to small size, it involved in the covalent bond formation. Along with that, aluminum also sometimes exhibit the covalent bond formation, BF3 and AlCl3. But remaining elements, as size increases, they readily loses electrons, exhibits electropositivity, and they'll show ionic nature. Okay, they'll show ionic compound formation. So this is completely about general characteristics of group 13 elements. Okay, thank you so much for watching.